just to give you a sense of what's going on, we are technically talking about multi-layer perceptrons today, which is sort of a very specific machine learning topic. But secretly, this is really about supervised learning, which is a huge, important topic in machine learning and in AI. And this is also really about getting comfortable using the tools of artificial intelligence to actually build things. We want you to walk out of here feeling like if you have an idea for some AI machine learning project that you want to create, you know how to do it. Without any help from anyone else, you can just start a project and make something cool. And so that's really our goal for these next 2 weeks, is to get you walking out of here feeling capable to do that. So again, we have this 2-week structure now, where we have this workshop today, and then part 2 next week. Today we're going to learn about how to do some of the things that we're trying to do, and walk through it all together as a big group. And next week, if you come back, you will join a team, and with your teammates, actually try to create something new of your own. You'll create a sort of brand new AI project that no one has made before, and it'll be all yours. And hopefully today will prepare you well to do that next week. And of course, there will be lots of rough edges, lots of bumps in the road, but we have a ton of people here to help you. And so this is a great place to learn about how to build things with AI. So yeah, the basic structure, the idea is today we walk through it all together, and then at the end, you can find a group that you want to work with next week. Hopefully you can find some people who you would enjoy working with. And then next week we'll be ready to go on some more independent work. So I want to give you a sense of sort of a big picture lay of the land of like, you know, this is AI Club. We kind of try to cover all of artificial intelligence, but there's a lot there. And sometimes it's hard to distinguish what are the different actually AI things that people do. A big category in artificial intelligence is machine learning. This is sort of the main, like, hot thing right now. It's really the huge thing that's going on, but there are additional types of AI where rather than having the machine learn, maybe we hand code a little algorithm that plays chess or something like that. We're not going to focus on that so much right now. We're focused on machine learning. Within machine learning, there are a few different kinds. We are going to be focused on what's called supervised machine learning. There's also unsupervised machine learning, where you essentially give the computer a bunch of data and say, tell me about it. Give me some categories, sort of sort it out. It's like you can imagine if you just had a big group of people and you said, hey, categorize these people somehow. That's sort of what unsupervised learning does. Reinforcement learning is like if you want the computer to play a game, and you're going to have it sort of play a bunch of games and then learn how to play over time. Supervised learning, again, probably the most common and most useful in sort of everyday applications. This is what we're focused on for the majority of the semester. We're going to be interested in supervised learning. The question is, what actually is supervised machine learning? I am curious. I took a picture here. That's my hand holding my TI-84 Plus graphing calculator. How many people had a calculator like this back in high school? Okay, quite a few of us had a graphing calculator like this. One of the things that these graphing calculators can do that's pretty cool is you can actually insert a table of data. So in this case, I went online and I found some statistics about different people and what their height is and how much they weigh, right? Maybe I could have gone and asked people, walk up, hey, how much do you weigh? I didn't do that. I went online and found a data set. And then I plugged into my calculator and said, here's some real-world data about how tall people are, how much they weigh. And then what this graphing calculator can do is give you a scatter plot that says, hey, look, if you know someone's height, here's their weight. And you can see, there's a lot of variance here, but there's a slight trend towards people who are taller are also heavier, which makes sense. And one of the key things that you want to do is figure out how to model that relationship. That if you have a whole bunch of data, you want to say, can I basically figure out what the relationship is? So if someone tells me their height, can I predict what their weight will be, roughly? And on the graphing calculator, you can go in and do a linear regression. How many people have done linear regression on their graphing calculator? Okay, many of us have seen this. Linear regression basically says, okay, I want a line that fits the data. And so you ask the graphing calculator, hey, can you find the line, the values of, in this case, A and B, or maybe we're familiar with it as like M, the slope, and B. Can you find me the values that make a really good fit for the data? And so the graphing calculator tries to find this line that goes through the data. And what's nice about having a line is that if someone tells me their height, they say, hey, I'm 5'3", I can go and look on my line at what I expect their weight to be. It allows me to make predictions where I say, hey, I had some data before, and now based on that data, I want to learn the pattern so that when I see something new, I can make a prediction. That is the key idea behind supervised machine learning. That's really what we're trying to do. You can think of supervised machine learning as being like, I have a big spreadsheet of data, I have a bunch of columns, and I want to predict the values in one of the columns. So if I tell you the square footage of my house and how many bathrooms it has and how many bedrooms it has and the latitude and longitude, I want to be able to predict the price of the house. Right? I'm trying to fill in what is the final piece of data, and I'm going to do that by looking at a bunch of training examples. And so this graphing calculator one, you're sitting there in math class like, okay, that's fine, whatever, it's a little boring. It's absolutely astounding if you take this same idea, but you just let yourself have a slightly more complicated model. You can do crazy things. And this is really a huge percentage of the AI developments and advancements that have gone on in recent years are literally just taking this extremely basic idea and saying, what if we allowed ourselves more complex models? So, yeah, here's the process. You gather data, check it out, choose a model, and then find the values that make it work. This choose a model type is really what we're interested in. There are lots of types of models. Linear is the one we just looked at. You could do a quadratic regression, where you say, hey, I think my data is going to look like a little smiley face, like a little U, and so I'll fit some parabolas of the data. And that's a little more complicated, and so if you have a slightly more complicated relationship, that might be useful. You can do exponential. Maybe you guys remember the PERC formula from back in the day. Here I have, I guess, perks. That's kind of fun. You can do, this one's interesting, a linear model, but it has multiple input values. This is like when I was talking about the house example, where it's like, well, how many bedrooms? How many bathrooms? I have lots of different numbers as input, and I want just a single number, the price, as output. I can do something that's just like a normal linear model, but it's like I have lots of different slopes for my lots of different inputs. Okay, all of these are still sort of mathy, sort of boring. Now we get to the fun stuff. In machine learning, we have one type of model called a multi-layer perceptron, which is a funny sounding name. Essentially, all you do is take a bunch of linear models and stack them together. So it's like, I'm going to take a linear model and it's going to give me an output, and I'm going to make another linear model that gives me another output, and maybe have like 10 of those. But then I'm going to take all those outputs and use them as my input to the next linear models. And so you just have like, 50 linear models all stacked together. And somehow, okay, with a little asterisk that we'll mention later, if I stack these together, it actually lets me represent much more complicated behavior. And so if my relationships aren't linear, they're like way more complicated. Where it's like, well, okay, the number of bedrooms is good, but if you're in California, it works differently, and all these different things. It can represent all those complicated relationships unbelievably well, right? It feels very simple, just like take a simple thing and stack lots of them together. It works crazy well, and almost all of the advancements that are happening in AI are from doing things like this. So this kind of model that we're focusing on today is good for predicting like a column of a table. Like I have a bunch of data, I want to predict one final value. There's also something called a convolutional neural network that we're going to focus on in the future. This is where you add something called convolutions into the picture. These kinds of models are really good for understanding images. So if you want to look at an image and say, you ever get the CAPTCHAs where it's like, tell me which of these squares has a, stop sign in it or something. That is Google gathering data from you so that they can train their convolutional neural networks to recognize stop signs. That's exactly what they're doing. They're collecting data from you so that they can train their models. So if you want to understand images or other grids of data, an image is really just like a grid of pixels. Convolutional neural networks are great. There's also recurrent neural networks where you add this concept of time. And once you have time, you can start to have sequences of things over time. So if you have text and you want to, well, you've seen ChatGPT, that chatbot that like responds crazy well. They're using something a little more complicated than a recurrent neural network, but this starts to give you the concept. So these are all these different types of models. They work just like regression on your calculator, on your graphic calculator. It's like I have some data, and then I'm going to train a model, and then I can use it to make predictions. It's the exact same process, we just allow ourselves slightly more complicated models. So, oh yeah, here's the little asterisk that I forgot to mention before. When you stack your linear models together, if you just have like linear and then linear and then linear, it ends up actually just being linear. You don't get any more complication. You have to sprinkle in what's called a non-linearity that basically adds some zest. But we're not too worried about that today. Okay, so that's the big overview of what you want to understand about supervised machine learning. It's like we have some input data, we have some output data, we want to train a model that can make predictions. And that's what we're going to do today. We're focusing on multi-layer perceptrons. I'm going to describe in more detail how they actually work in a little bit, but I figure if I just talk for so long, it gets boring. So we're going to explain that later. For now, Uzair is going to walk you through the process of going out onto the internet, gathering some data, cleaning it, which is important, sort of poking around, getting a sense of how it works, and analyzing that data all from scratch. So you're going to do this totally yourself without any sort of template to start from. But Uzair is going to walk you through it. And by the end of today, we're going to have a really cool model that can make predictions about, I think it's penguins. And you will walk away knowing how to make models like this, so that next week and then in the future, you can train a machine learning model to make any kind of predictions you want. So that's the promise to you by the end of today. Uzair is going to walk you through it starting right about now. And he's just going to talk you through essentially the process of doing this. And what I want you all to do is follow along. So he is actually going to create a Python notebook and do this from scratch. And I want you to try to basically copy what he's doing and then play with yourself and make some tweaks. But essentially try to copy what Uzair is doing so that you can see the entire process step by step. So make sure you have your computer out and ready. Be ready to sign into a Google account and all that. And try to just follow along and copy what's happening. And then we'll give you plenty of opportunities throughout to explore and go around that.
Okay, testing. So I'm excited to have you all here. The first workshop of our new format. As Josh said, multi-layer perceptrons are really exciting. Just like the linear model we saw, it's interesting how you can have a linear model which has like two parameters, but pretty much every supervised model we see in AI is based off of that. So for example, ChatGPT, instead of having just 2 or 3, it has like several billion. And we're going to teach you about, from start to finish, how to build your own multi-layer perceptron. So today's going to be like a collaborative day. If you're sitting next to someone, hopefully you got a chance to get to know them. If you're sitting alone, you might want to move to a table so you can talk to your peers and work through this together. We're going to start. So we're going to go on Google Colab. So if you have a browser, just go to Google Colab. And to use this, so this is basically an online Python like notebook. You can so you probably will have to sign in. If you don't have a Google account, you'll sign in a Google account, and make sure to use your personal Google account, not your MSU account.
And if you ever get stuck or have issues you're not quite sure, certainly you can ask the people around you, but also you can throw up a hand, and some of us will be wandering around to help with anything.
Okay, I'm just gonna read all the sample code. Yeah, so if you ever fall behind, just feel free to, I'm gonna take some breaks in the middle. You can like talk to your friends and get caught up. Okay, so today we're gonna go like all the way from start to the finish. So from finding a data set online to creating a model and making predictions with it. So this is what we're gonna be doing as well afterwards. A great place to look for data sets is Kaggle. It has all sorts of data sets, especially for prediction. And in this case, we're just going to use this one for a sample. If you've ever taken like statistical, this is a really famous data set. So let's go with this one. If everyone's following along so far. If you have any questions, you can just raise your hand and we have people who can help you guys out.
Yeah, so again, just to be clear, at this point, hopefully you've opened Google Colab and you've opened Kaggle and have found this penguins data set. This is kind of following along we're talking about.
So for a bit of background.
And again, it'll take time for people to sign in and things, so we'll give you a minute, but yeah. You'll want to sign into Kaggle as well, I think, in order to download the data set.
That's right. For a bit of background, while you guys are getting this set up, Penguin is like a data set that was collected a couple of years ago from 3 different species of penguins. And we have data about different biological characteristics of the penguin. And what we're trying to do is classify what species the penguin is based off of things like the length of their bill, their height, their weight. Knowing nothing else, we're trying to predict their species. And there's 3 different species. Okay.
Raise your hand if you are signed into both Google Colab and Kaggle, if you've successfully signed into both. Okay, and raise your hand if you have not yet, if you're still working on it. Okay, so we can move on pretty soon, and everyone who's still working.
Sorry, don't worry if you're a little bit behind, I'm going to take some time this second. We use Google Colab a lot.
Which data set are we using? Penguins? This one?
So our next step is to kind of understand the data set. So if you guys are on the laboratory, Google Colab, you can go to Kaggle, just search a penguin, and this data set.
Everyone be quiet down for just a second.
Okay.
I know you're talking to your people around you, that's great, but when Azar is talking, we will pay attention and make sure we know what's going on. Alright, go for it, Azar, and project, talk loud.
Once again, it's alright if you guys have, confusion along the way. I'll give you time to figure things out. So, can everyone let me know what is this one? Can everyone let me know, has everyone found the penguin data set? Can I get show of hands? Who found the penguin data set on Kaggle? Okay.
You got it.
So, go ahead and go over here. When you see, you might not find this exact one, but most of them are like this. There's a tab called data card. Go under there, and there's a download button. Okay, it'll give you a CSV file. And once you have the CSV file, you can go into Collab. Go to the left, where you'll see this folder icon. Upload a file, clicking on that, and then select your thing. Don't worry about the warning. And now let's try to understand our data set a little bit. So we can use pandas, which is a very common data science library. Okay, so we get a table. We have it uploaded into our notebook. So the next step is to get to know this data a little bit better. So there's a number of different visualization you can do. But before that, usually when you're working with data in the real world, it's not perfect. And same with this data set. Sometimes you find a penguin and you lose some measurements or you don't get accurate measurements. And that will mess with you. So we want to check if there are any invalid values and we want to get rid of them. And most of the time you'll have to do this. In this case, for simplicity, we'll just get rid of all of the invalid values. And there's one way to do it is that it's like this. So first to check how many there are. All this does is it counts the number of rows that have NA values. And it sums them up, and you get to see how many values there are. So now we can use.
By show of hands, how many people are following along right now? How many people feel good? And how many people feel lost or behind? Okay, let's give everyone just a second to catch up here. I think we got some people who are behind. Scroll up.
Okay. If you guys are at all lost at any point, just raise your hand. To help you.
Did you get it? Hold on. You can do. So,
is there anyone who was not able to download the data set from Kaggle and get that penguins.csv up? If you're not able to download it,
so just type it in. Yeah. That's all. Okay, that's good.
Yeah, it's a, I don't know.
I'm wearing glasses. I still can't see underwater.
Might need some new glasses, sir. Something.
You just put the one budget in.
It'll take longer.
Okay, looks like everyone's for the most part. If you fall a little bit behind, don't worry. Just try to follow along visually. If you fall too far behind, you can just follow along with people next to you. Okay.
Alright, let's final conversations for a minute. I love the talking. We'll get a few more instructions here and then you can go back to collaborating with people around you.
Okay. Yeah, so I'm going to understand the complications here at the beginning. We're going to get to the fun stuff in a little bit. So after we drop the invalid values, the next step, so by the way, I froze the middle of the screen in case anyone wants to see the first few parts. After we drop the invalid values, we can visualize what's going on inside of the data. So this is the data about penguins with like 2 or 3 different features. What we can do is do a scatter plot of one feature against the other, and then also color coded by the species to kind of get an idea of what's going on. So what we're going to do is use matplotlib. And then we can use the function, we can use scatter function. So with the name of the so now the inputs to this are the x and y values and then your label. So what I want to do is you guys can also play around with this a little bit. You can say let's take the bill length value and the program. This gives us a nice scatter plot, and we can also add, we can also see that you can see this kind of clustered in 3 areas. And to make this even more clear, you can add another parameter.
Is penguin standard?
Okay, so you should get the error completely expected. So what we want to do while we're modeling data is use numerical values. So you can see that the species is categorized as 3 things: Adeli, Chinstrap, and Ginsu. And you can see you don't have to do this for demonstrations. You can see there's 3 different ones. So we want to convert those to number values. Just because it's easier for the perceptron to classify numbers than it is to classify strings. And the way we do that is this was a mistake, by the way. Oh yeah, that's mostly data that's dropped in. And then new data. So we're going to replace this with numerical values. So replace. in a spelling language, and we're going to include a dictionary. It takes in a dictionary of mapping between strings and what we want to place in it. So let's say we want to replace all instances of identity with a 0, and then change that with 1. Oh.
Alright, how many people are following along and feel ready to keep going? And how many people need some time for a minute? Okay, we'll give a bit of time.
Yeah, we don't have to raise your hand if you're okay.
It is special. Oh. There we go.
So this is just a Oh yeah. Is there anyone who feels totally lost and hasn't gotten help yet? Okay, so
I'll just stick that in there.
There
you got it. Ah, there it is. You're good. Oh, I had a typo.
I didn't have my data.
We got some data. Do some. Oh, this could be very nicely defined.
Imagine that.
But almost as if they chose this data set for a specific reason.
Anywhere between 5.
Gross.
Supervised.
So
You have to develop a model.
okay. I mean, for a capstone project, that's pretty good. 120. Okay. That's not. That's a lot. Yeah. How long did it take to train? Dude, not training. Okay, that's not too bad. That's.
Alright, let's get another show of hands. Who feels ready to move on? Who feels ready? They're kind of waiting, they're ready to go?
Yeah.
Alright, and how many people feel like they still need more time? Okay, we'll give a little more time still then. Give it a time a little bit more.
Oh, that's so much better.
Yeah.
Question. Do you guys have to type fast once you get into the outside program? Like the demand started increasing?
By yourself. Right.
So you're saying it's okay, but your life is going to be.
No, it's not. There's not a lot of technical stuff. Check it out. That's not
It's like how good you just think. Okay.
Did you type? Sure.
You get it all anyways.
Yeah.
I've done it, next season is funny. It's terrible. Well, I'm not looking at it, I'm just curious. That experience was so bad. For some reason, programming just does not.
It's like a.
It's literally fun. One of the problems as a programmer. It's like, unfortunately, I'm just bad at one. When you question how I make it, a lot of following, do step X, Y, Z. Circuit analysis, do step X, Y, Z. There's nothing to it.
Unfortunately.
It's just rather annoying. So you can make it on this.
Okay, guys, everyone remember to do in place equals true when you're trying to modify the data species you have replaced if you're not doing the data species equals something you have replaced. Because a lot of you are getting errors in that. So.
Like, literally, I mean,
Like you did.
say it's like underscore, like, come on, running this. That does not make you want to make you bang your head so like an hour. Oh yeah, by the way, there's underscore.
Okay, I've frozen middle three to monitor to so they catch up. But the next few parts are just visualization. You don't need to copy down what I'm typing. Just you can just follow along visually. Again, this part is optional. The visualization part for the next few parts are a little bit more involved. If you just understand what the graphs are representing, that's good.
I don't think I've ever seen it.
So,
First time? You know, it could happen.
but in the interest of time, you can just follow visually for now, and then when we get to the actual MLP part, we'll continue working with the data. So we can also.
Oh, you already. So, there's means already on top. I just did that. Yeah, but like, I'm going to do it. I'll just like,
So another really good visualization library is Python called Keyboards. Again, you don't have to follow along if you want. You can follow along, but don't worry. So this allows you to visualize data that has a lot of interrelationships between many variables.
Do you want to mess with
And especially for something like this.
okay.
Like four
inputs. I was gonna wear the t-shirt. I know it's fucked up. I can't control my brightness.
So this is something called a air plot, or I can go back to other names. In C1 it's called a air plot. And this, it takes a while. It allows us to visualize the relationships between all the different variables in the data.
This one is going to take a second to run, by the way. So if you run this code, don't be surprised if it takes a minute. It's going to make a lot of scatter plots.
Yeah. Okay. So there's a lot to take in. Let's zoom into one little cell. Okay, ignore this one. So we have the independent variables on both of the axes And basically, it's a bunch of scatter plots between all of them, and you kind of visualize the relationships. We can go into that more later, and you might be familiar with significant data science classes, but if not, just know that if you see patterns like linear relationships, that means that two variables are kind of correlated with each other. And you kind of see that if you draw a line through these, you can separate the different species of penguins very easily if you look at certain features. And so we're going to take advantage of that here to build a machine learning model. So now what we want is to only select the columns that are interesting to us. So let's take a look at the data again. We don't want this first column. We don't want the second column. The column that we're using to the variables that we're interested in are the build length, the build depth, slipper length, and the body mass. Those are going to be the 4 parameters for our perceptron. So we're going to make a variable called x. And x is kind of analogous to your x in a linear regression. It's your input to your function. And what the model learns is what function to apply to x to get the output you're trying to predict, which in this case is our species. So this is going to be, let's say, so this is just Python notation. If you're not familiar with it, that's fine. But we're going to start from the third column and go to the second to last one. Let's see if that's good. Okay. Okay, there we go. For some reason, there's still any values in there. Okay, so once we have this, I'm going to give it a second for everyone to get caught up. This part, make sure you have this part down.
To the previous smart growth filter.
Which one?
There we go. There we go.
Yeah.
There we go. Scroll down. All right. There we go. Wow. Perfect. Thank you. No,
Alright, how are people doing? We'll get another show of hands. How many people feel ready to go on to something new? Okay, and how many people need help or need time? Alright, I think we're ready to keep going.
Okay.
Is there anyone still using that middle screen who wants it to be frozen still, or do we want to go back to... Raise your hand if you still need it frozen. Okay, we'll unfreeze it.
our input variables, which should look like this. And now we want to get our variables that we want to predict, which is the penguin species. And that is just, we're going to call that y. We're going to say just the species column. So use square brackets to index it, and it's called species, and then it looks like this. It should be a vector of numbers.
Yeah, and just to be clear on this, remember the graphing calculator analogy. What we're trying to do is take some input data and then train a model that can guess the output data. And so x and y, x is your inputs, y is your output that you're trying to predict. And so this is the training data, this is the data that we are training our model on, but we hope that in the future the model will be able to predict the species based on that input information. That's where we're going with this.
Okay. So next step.
Let me freeze that.
Okay. You want to freeze it over here?
Okay, go ahead.
So the next step is to split the data into.
Is this where I should jump in? Or are you doing
One second, yeah. So we want to split the data into training and testing.
Hang on, before we do that.
And the reason why it's important is yeah, Josh, you're gonna explain.
Who's there? Tried to cheat me out of my presentation. We've got some fun things to talk about. Dude got carried away over here. I have some things that I want to tell you. I feel like that was a lot of working, a lot of dealing with the nitty-gritties here. I want to go back and just give a broad sense of what we're doing again. So far, we've taken our data, made a scatter plot, sort of trying to get a sense of what's going on. Do we understand the data? Do we understand the relationships? Now our goal is to train a model to look at these different x's and y's and be able to start making predictions. So if you have the measurements of a penguin, can you predict what its species will be? In order to do that, this is where we start to get into the multi-layer perceptron idea. Before we make a multi-layer perceptron, I just want to understand what it actually is. Again, this is what a linear model would look like. This is the idea where you have, okay, I have, maybe I know the flipper length, and I want to predict the body mass. Probably there's a fairly linear relationship there. I could make a model that looks like this. And I actually went and did this in Desmos. I made a scatter plot of flipper length versus body mass, and you can see I made a linear model that does a pretty good job. This would be a pretty successful model if you wanted to just measure the flipper of a penguin and then figure out what its mass was. You could do that using this model. If you wanted to do an even better job of predicting the body mass, you might do a linear model with multiple inputs. So you say, okay, I know the flipper length and the build length and the build depth. That gives me more information, and I can probably predict the body mass even more successfully. So again, this is just sort of a linear model. I want to make a diagram of this linear model. Oh yeah, here's what that looks like if you have multiple inputs and one output. It's fun, you can actually make 3D scatter plots. We're not going to do that today, but there is some code for this that we can show you if you're curious. I want to make a diagram of this linear model. It'll seem kind of unnecessary. It seems like overkill, but you'll see in a second why having this diagram is useful. If I have my 3 inputs, the flipper length, the build length, and the build depth, and I want to sort of calculate the body mass, I'm going to take each input and multiply it by some like slope, some m, right? That's basically like how proportionally much do I care about this value. And then at the end, I'm going to do a little plus b. I'm going to add what's called a bias, which is just this little extra value to give us more control. And so this diagram essentially shows you how you can take the inputs, multiply them by the weights, we call them, add a bias, and get an output. This is just a diagram of what this model is doing. And if we were going to train a model like this, we would ask the computer to figure out the correct values of m, m1, m2, m3, and the correct value of B that gives us sort of the best possible predictions. But what if instead of body mass, I was trying to predict the species, which is the thing that we actually want to do? You could try to make a model that just outputs 0, 1, or 2, because we sort of label the species that way. But that's a little weird, because if you label them with numbers like that, somehow, I don't remember what the 3 types were. Can anyone tell me, what were the 3 types of penguins? Like, what was the middle one? What was number, out of 0, 1, 2, what was number 1? Does anyone have it?
Chin strap.
Chin strap was number 1. If you just label them 0, 1, 2, it sort of implies that chin strap is like in the middle. That it's somehow like if you average a 0 and a 2, you somehow get a 1. That's not really how it works, right? So just using numbers that way is not so good. What we really want is a model that gives multiple outputs. It would be really cool if you could give 3 different outputs, where one output is the probability that it's this first type of penguin, the Adele, I don't know. The second output being the probability that it's a chin strap penguin, and the third output being the probability that it's a Gen 2 penguin. Right? If we could give 3 outputs like this, then this would work a lot better. And actually, this diagram shows that you essentially can just by creating 3 different linear models. One linear model that takes the inputs and predicts the probability that it's the first one, a second linear model that predicts the probability that it's the second one, and a third linear model that predicts the probability that it's the third one. You just have 3 diagrams, and these different yellow lines represent the weights. That works pretty well. But if you remember earlier, what we said was you really want to stack a whole bunch of these linear models together. Because a plain linear model like this can only capture simple relationships. I mean, they have to be linear relationships, right? It has to be like, if the input gets bigger, the output gets bigger, or vice versa. Sometimes your relationships are more complicated than that. And what we can do, the extremely clever and yet simple trick, is to make a diagram that looks like this. You add what's called a hidden layer. It looks a lot more complicated, but it's basically the same thing. I take my 3 inputs, and I have 6 different linear models. And each linear model gives me some value in this hidden layer. And the values in the hidden layer don't really mean anything to us humans. It's like, I'm not really sure what the 6 different numbers are telling me. But I just take those 6 numbers and use them as inputs for more linear models that give me the actual outputs that I want. And somehow, by some great miracle, just adding this extra complexity, letting the model be more sophisticated, actually lets you model much more complicated situations. Again, with the asterisk up, we need a little nonlinearity in there. We're not so worried about it. So you can add as many hidden layers as you want, and your hidden layers can be as big as you want. And essentially, it's like the more you add, the more complicated your model can be. And so if you have a really complicated relationship, often just adding more and bigger hidden layers will let you model them. It's like almost everything is just a whole bunch of linears stacked together, and yet you can model really complicated things. However, okay, here you go. So this is the sense of what the inputs and outputs mean. A more complicated model isn't always better. This is a really important and not immediately intuitive idea. A more complicated model is good if you need a complicated model, if the relationships you're dealing with are sophisticated. But I want to show you an example of a complicated model that's worse. Here I took some training data. This training data, I should have fit a line to it. I should have just used a linear model, and that would have been pretty good. Instead, I created this complex polynomial with powers up to 7, right? A degree 7 polynomial. It's a really complicated thing. This complicated model technically does a better job on this training data. But I think we can all agree that it's actually a worse model of what's going on. And one of the ways you know that is if you plug in, I think this is still like predicting, I think this is the weight versus height data. It's like if you plug in a height of 240, it should not give you a weight of like negative some pounds. That's a really bad model. A much better model would be simpler. So you want to avoid this problem called overfitting, where you have a model that's too complicated for its own good. And in this case, it's really visually obvious that you have a model that's too complicated. You can just look at it and go, yeah, that's a bad model for the data. But when you're dealing with more complicated situations, like our penguin example, where we're trying to predict the species based on these 4 different inputs, I can't really just make a picture of my model, and so I can't really see visually if it's overfitting. And so the question is, how do you measure if a model is overfitting or not? And the answer is that when a model is overfitting, it works really well on the data that it has seen before, but it works really badly on new data. And that's exactly what we had going on here, where we said, look, my model is like really good on these couple 5, 10 red points that I trained it on. But as soon as you go outside that, it does a terrible job. That's how you know your model is overfitting. So if you train a model, it does really well on the data that you trained it on, and then you go to use it in the real world and it sucks, that means your model is overfitting. And that means that your model is too complicated, and you should try a simpler model instead. So this is such a big problem, having models that overfit the data, is such a huge issue that it's actually crucially important when you're doing machine learning that you take your data set and you stash a little bit of it away. You take maybe 10 or 20% of your rows and save them for later. And what you do is you train your model and you only show it 80 or 90% of the data. You don't show it the stuff that you saved away. Then, after you've trained your model, you put it to the test. You use that data that you hid as your testing data, and you say, okay, model, I trained you on some data, but I have some more data that you've never seen before. And I want to see if you can make good predictions on this new data. And that's your way of checking whether your model is overfitting or not. If you try it on the testing data and it's really bad, then you've done something wrong. There's no way to fix it other than to go back and change your model to be simpler and retrain, but it's good to at least be able to identify that there's a problem. So every single time you're doing machine learning problems like these, you're going to split your data into training and testing, and then you're going to save that testing data for later, and at the end, you'll use it to see if your model is doing a good job or not. So that is the thing that we're going to do next. We're going to split our data into training and testing, and then we're going to actually make a model. And so that is sort of the final thing that we're going to walk through here. Uzair is going to help you do it. We're going to get back into the notebook, do a little bit of that, and then that'll be our day. And next week you'll be ready to try doing this on your own. So we'll give it back to Uzair here.
And then,
Okay, so yeah, in the real world, there's always an element of randomness. Just like in the tango, where the model might learn the randomness.
Yeah.
So you might have 100% accuracy on the training data. It might be so accurate that it predicts everything on one of our penguins correctly. But when you go out and find a new penguin, there is a little bit of
he seems fine. Just
there's
need to figure out what it's happening.
there's not complete certainty as to where those slides came from. So you just memorizing the input data from a really complicated model might be problematic. So when we combat that is by splitting your data into 80% training data, which we'll use to train the MLP, and then 20% of it will be the testing data, which will come into play later. Here's the end of this. And you always want to do this in machine learning. So there's a very useful library in scikit-learn called train test with we're going to use. And then There's also another step which I'll briefly go over. You don't need to worry about the details of it, but it's also going to make our model like 10 times better. And it doesn't make complete sense, but it is necessary. So we're going to go with import. Then direct from model section. Okay. So we made our x and y layer here. So what this takes is your array that you want to split, in which case we have x and y, and the last parameter is the percent of our values we want to be testing for. So it's test size, and let's just say you can usually go with like 0.2, and that's fine. And then this function will give you a lot of outputs, and we want to put them in this exact order.
That makes sense. That features the place to go.
X test, X train, Y test,
like a little key file that I'm sure you guys
and Y train. Okay. So X, so the testing for the X and Y.
Next year.
This is what I'm going to play near the end. For now, we're only worried about the training X values. So the model will use our X values and our Y values to try to figure out the parameters for the multi-layer perceptron.
Yeah, I'm more focused on this.
So this, as you can see, this should only have about
just open. It's actually kind of sick.
S59.
So we have to have a team. Yes.
And
yes. You already started.
Okay, this should. So the order goes train test and the first is train. So I mistyped this. So it goes X train, X test, Y train, Y test. Okay.
Is this like Jeopardy style?
It's gonna be like.
Yeah, this can get a lot so confusing. Yeah. I know this one is still get this mixed up.
Here, there's 7 different ways you can get a flag.
Okay, there we go. We should have the majority of our rows inside of X train. We want to use most of our data to train this model. Okay.
The Texas Instruments. We're booting the reference design.
I'm gonna leave it here for you guys to catch up a little bit, and then
to get this flag for just booting the.
How many of you guys are still working on this?
Get a flag. We have to design it.
Is anyone ready to move on?
Switch it. That's fine.
Okay. You want to freeze the middle?
No, that's the biggest.
So now,
7 last week.
This is on the graphic calculator analogy, basically the behind the scenes magic, where once you give the calculator the input and output values, it will use its linear regression to give you a function. And in scikit-learn, we have something called an MLP classifier.
Design flag is you spend time coding on the side, like once a week.
And basically, this will take in our data and will give us a multi-layer perceptron with all the parameters that it will train with its own parameters. And we don't exactly know what's going on behind the scenes. But those details are important for now. So from
design. Oh, that was submission by March. Yeah.
You guys do like Jeopardy style?
Maybe this can be like Pico.
Cyber. Or H2.
Yeah, those would
try having this one.
Try this one. Sure.
So for now, we are using the MLP classifier from scikit-learn, which works very well for our case. And if you want to do more exploration, in the future we'll teach you how to go and fine-tune it even further and understand, like, let's say you want to change the number of layers, or you want to change the type function that you pick. That all affect the model. And that's all part of the computer spectrum. What this does is it does all that for you. It basically chooses all of the, I would say, hyperparameters for you. Basically like in one line. And you can use it with this
side channeling. Some people post like their answers on Twitter, which is pretty sweet.
So here's where you can put in any optional parameters. For now, we're going to leave it blank. And then,
so far we have 6 of us. We have a stack team, we have a detail.
And so again, just like the graphics calculator, what we're giving it is our training data. It needs the x value, that is all the features of the penguin, and then it needs what the features of the penguin are. And using this, it'll create a model, which we call CLF, which is basically a classifier that we can then use to classify penguins. And when we run this cell, it might take a little moment, and then it should give you a classifier. Okay. You still have any values.
Okay. So you're going to cover. There's like
I want you all to know this happens to every single person. You will never ever write code that works in your entire life on the first try, and that's okay, and that's normal. I want everyone to internalize that. I think it's really easy if you're getting started with programming or with data science to think that errors are bad. Errors are not bad, they're normal, and it's what you expect to have happen.
That's not bad at all. There's especially with all the layouts. Yeah.
The question, of course, is why did this error happen? And the answer is I have no idea. But is there a return? Or something like that.
Even though it's like this is exactly
physical defense, because this is literally like what I'm gonna try to do is if I do this in CTF, I can ask them to program physical security team.
I think you answered themselves. So still called data.
Yeah.
Can you just do runtime?
Yeah, this one didn't have this one had any errors. I think I know what happened.
It's like a casual, so casual. As long as you get your data analyzed, that's it.
The checking long machine probably works. Okay, so yeah, just I think hopefully none of you copy this mistake, but you have to do data equals data drop any. And this actually drops any value.
Yeah.
So data equals data drop any. You see with this data drop any.
Yeah. Yeah. They're all definitely looking for talent, but I think they have some people. Yeah.
How many people were able to run this line, MLP, make a classifier, and get the little green check mark? That nothing particularly happened, but you got the green check mark that seems to say things are good. Okay, we got lots of success. That's cool.
So we're walking through the whole process with you guys from start to finish. And usually half that process is fixing errors.
Feels like the old stuff. Yeah, drawing actually, yeah. Yeah. I must fight him. So no more type executive. Didn't like him for some reason.
So once you have the classifier, you can now use it to make predictions.
Yeah, I was the guy who asked.
This is pretty much most of the work done.
Yeah.
Most of the work was
now he's just
this line,
he's like,
but the computer did it for you. in the future, when we go into more neural networks, you'll learn a little bit more about what's going on behind the scenes.
He's chilling.
Especially if you plan to come back next week and work on your own problem. You might want to learn about how what kind of optimization you can do. For example, if you guys, if you're on Windows, you
I want to say hi to
click
Picard things because
on MLP classifier.
nah, I probably not too because
Or if you're on command, click on MLP classifier.
yeah, I'm not trying
And
to
then it will pull
break
up
out.
the documentation. It has all sorts of different parameters that you can play around with if you want in your own time.
Because I don't want to, go through that.
So, for example, you can tell it how many iterations you want to do. You can tell it the learning rate, and all those specs I can see somewhere. Okay, so now we're going to move on to the final step, one of the final steps, which is to make predictions. We don't know how good this model is yet. All we know is that it's trained,
At the house?
and it might be really bad.
Oh. Oh shoot, I missed it.
So we can do PLF. Done. Do another cell.
And I don't know.
And then
There's like 5. Do you play on a timer or?
which is called
Well, we were doing like 5 minutes.
Okay. You gotta keep it quick.
Yeah, I was going to do correspondence.
Oh my god. People can take the time. Sometimes. Plus it's fun at 5 minutes because people
So this is a really exciting moment for those of you who are following along. We created this classifier, we trained a model, now we're actually using the model to make predictions. And we're saying, hey, remember that testing data that we stored away earlier?
So
You should try to predict what the y values are for that testing data. And then the interesting question is, do the predictions from the model match the actual data? Was it able to successfully classify these different pigments? So let's make sure everyone understands what's going on there.
So we did one.
So think about it like this. We have our X test, and what X test is, you have just a bunch of penguin features. You have penguin number 93 with these exact features, and the model was told all of the species of all these penguins. And it took that, and using some magic, determined its own parameters to transform this data into a label of either 0, 1, or 2. And so, penguin 93 is a 2, which I forgot which one that was, but it's the third species. So we can use this to predict what species the penguin is. And you can use this in all sorts of different scenarios, which we're almost done. And then we'll go over what other application you can do with this. And this is the classification type problem. And now we want to test how accurate this is. You can do that in the here before.
How did you hear about it?
Using your
There you go.
testing.
Word of mouth is spreading. That's powerful.
Everyone who didn't do the drop NA first, please run all the cells from the drop NA code class till the end. Otherwise, it's still going to give you the NA error.
So you can see that it's only 44% accurate. So let's see what happens if we go into here. And I change the iteration.
That was kind of like, there you go. That's a low ball. The basics. Okay.
So there we go. That's the MLP model.
That's it.
How much time do we have? Okay, so we have like 10 minutes. Do you want to go over the next two?
Yeah.
Okay. So today, hopefully, you met the people at your table. The goal for this week and next week is to do exactly what we did, but choose your own data set
So now
rather than Tango. You can go on Kaggle
there we go.
and go on your data set. Yeah.
Because that the projects
Okay,
at the
last
end
time
are
we
probably
go
so
over
exciting for data.
what's happening.
It's literally like the best data. You
Okay.
It's on.
We are running out of time here, so I want to wrap it up. We were able to successfully train a model here, and hopefully at the very end there you caught measuring the accuracy of the model. There's one more thing that we want to do before we leave.
That's fair. I was like, listen, it's a secret.
If I can get your attention here. There's one more thing we want to do before we leave. We'll put the code back up in a minute.
You don't have to be the guy who talks about his work the whole time.
But I want to talk about next week. Today, we were having you follow along with us. You were sort of following what we were doing, trying to get a sense of how this whole process works.
Because it's so much easier.
The idea is that next week is your turn.
Yeah,
We're going to give you a bunch of resources, we're going to give you help, but it will be
fun.
your turn to try to make a model just like this, using a data set of your
Especially
choosing.
since you DJ now, you're just like.
In order to be ready for that, you want to work with a team next week. You're going to pick a few people, probably the people sitting around you, although if your friend is on the other side of the room, that's great. You're going to pick a few people and work together next week to choose a data set and then train a machine learning model on that
Is that
data.
like the
So,
southwest side area? Okay.
But it's like you just
what we want you to do is find a group with the people around you who you'd be interested in working with next week and fill out this little Google form. And on this form, you're just going to put your group member's names and a Kaggle data set that you're interested in using. Go on Kaggle.com, find a data set that you think is interesting, and just send us the link. And we'll take a peek and make sure that it's appropriate. You want to choose one that basically has a table of data in it, because that will work well for Multi-Layer Perceptrons. So try to find a group of the people around you. I said 3 to 5 people. If you just want to be a parent or something, that's great. But find a team, and then one of you fill out the Google form. And next week we will try doing this in the